Hi, I am Akhilesh Kumar Srivastav from ABES Engineering College, Ghaziabad. In today's lecture, I'm going to discuss about a Codechef problem, which is one-dimensional kingdom. This problem resembles with one of the classical programs of greedy method, that is activity selection problem. In this lecture, we will try to first know how to solve the problem of the activity selection. Then we will try to correlate that problem with the one-dimensional kingdom. We will make the required changes in the solution of the activity selection problem so that it becomes the solution of the one-dimensional kingdom, and then we shall code that at the Codechef platform. Let's look at the problem statement. So here is the problem, which says that n one-dimensional kingdoms are represented as intervals of the form ai, bi. On the real line, a kingdom of the form L, R can be destroyed completely by placing a bomb at a point X on the real line in between L and R, including L and R. Your task is to determine the minimum number of bombs required to destroy all the one-dimensional kingdoms. So let's try to understand this problem with an example. So let's say we are given one test phase and which is representing three kingdoms. The first kingdom has a boundary 1 to 3. So if this is the real line, the kingdom 1 is represented as a line 1, 3. The kingdom 2 is represented with a boundary 2, 5. So 2 will be somewhere here and 5 will be somewhere here. So this is representing kingdom 2. And the kingdom 6, 9 is somewhere here. It means the kingdom 3, which has the boundaries 6 and 9, is somewhere here. So if I take the line from 1 to 5 and the line from 6 to 9, then I can take a bomb in between 6 to 9 and I can destroy the kingdom K3. If I take a bomb at a place 2, then I will destroy 1 and I will destroy kingdom 2 as well. So it means that I require only one bomb to destroy the kingdoms 1 and kingdom 2, whereas I require one bomb separately for destroying the kingdom 3. If I look this problem with respect to the activity selection problem, so perhaps the solution will become even easier. For example, I take the same example and try to look at this problem with respect to the activity selection problem. Suppose we have been given a computer, which is the uniprocessing system or uniprocessor system, wherein I have only one processor and it can schedule only one job at a time. So if the jobs given to us are starting at 1 and starting at 3, the activity 1, let's say, or job 1, the activity 2 starts at 2 time and finishes at 5 time. Activity 3 starts at 6 time and it finishes at 9 time. So I have to decide that how many maximum activities I can schedule on this processor. So for doing or for solving this, what we do, we sort these activities based on their finish time. So this is representing the start time and this is representing the finish time. So I will sort this according to the finish time. Incidentally, these activities are already sorted according to the finish time. So let's schedule the activity number 1 on the processor. The activity number 2 can be scheduled, or second activity can be scheduled only after finishing the first activity. It means before scheduling any activity on the processor, you will have to check if the starting time of that activity is greater than or equal to the finish time of the current activity. So current activities will finish at time 3. If you check for A2, its start time is 2 which is not greater than 3. So you cannot schedule the activity number 2. If you see the activity number 3, which starts at 6, so yes, you can schedule this activity because its start time is greater than current finish time. Current finish time is 3, so you can schedule this activity 3 on the system. So you were able to schedule 2 activities in this case. Let's take another example. And if I take that example, before taking that example, you can also say that you require 2 bombs. As many activities you are scheduling on the processor, the same is the number of the bombs if I look at the one-dimensional kingdom problem. Let's take another example, which will change our point of view a bit. Let's say we have 4 different activities. Let's say activity 1 starts at 1 and activity 1 finishes at 3. Activity 2 starts at 3 and it finishes at 6. Activity 3 starts at 6 and it finishes at 9. And activity 4 starts at 8 and it finishes at 10. Now, if I schedule these activities, let's say we are first sorting these activities according to the finish time, which has already been sorted in this case. So let's schedule this activity number 1 on the real line or on the processor. Activity 1 will finish at 3. If I look at the activity number 2, it has a start time 3. Since this is equal to the current finishing time, we can schedule this activity. So activity 2 has been scheduled and it will finish at 6. Let's look at the activity number 3. It will start at 6 and finish at 9. So the starting time of this activity 3 is actually equal to the current finish time. So I can schedule the A3 activity also. If I look at the activity number 4, it has a start time 8, which is not greater than the current finish time because the current finish time is 9. So I cannot schedule this activity 4. It means I can schedule 3 activities to the maximum. If I look at this problem with respect to the one-dimensional kingdom, and this 1, 3, 3, 6, 6, 9, and 8, 10 are representing the boundaries of the kingdoms, then you can say that 1, 3, for destroying the kingdom 1, 3, and 3, 6, you don't require 2 different bombs. You actually require 1 bomb only. If you place a bomb here, then this will be destroyed, and this will also be destroyed. Similarly, the boundaries of A2 and A3 are also matching. So if the boundaries are matching for the 2 different kingdoms or more than 2 different kingdoms, then if you place a bomb at 6, then these 2 will be destroyed and this will also be destroyed. So for solving this problem, you just see that you require only 1 bomb to destroy these 3. And in fact, the boundaries of A4 is overlapping with the boundary of A3, so 8 to 10. So this A4 will also be destroyed in the single bomb. So when you were scheduling the activities, or you have taken the activity selection problem, then you were checking if the current activity's starting time is greater than or equal to the current finish time or current time, then you were scheduling the activity or you were incrementing the number of activities which can be scheduled. When you are solving this problem or the one-dimensional kingdom problem, you will not check equal to. It means if the end boundary of a kingdom is greater than the current boundary, then in that case, you require to update the bomb or the number of bombs will be increased. In case it is greater than, it is equal to or less, in that case, you require the same bomb to destroy the kingdom. Let's write it completely, the pseudocode, which will actually make us convenient in writing this code at the Codechef platform. So we have been given the start and the end boundaries. So let's say the kingdoms and the start boundaries are represented as SI and EI, where SI is representing the start boundary and this is representing the end boundary. So if you have n kingdoms, and for n different kingdoms, we will look at this one and we will set the current time, let's say at 0. We are assuming that all the times will be greater than 0, all the start times will be greater than 0. And if the current time has been set as 0 or the current boundary has been set as 0, then for all the activities that we have, let's say we have n activity. So for I equals to 1, I less than or equal to n, and I plus plus, if we are representing this in the form of the array, then we will have to start the index from 0. And this will change to less than, because the last index will be n minus 1. These activities have already been arranged according to the finish time. That's what we are assuming. So if the start time, or you can say the start boundary of any of the kingdom, is greater than the current boundary, let's take the current boundary instead of current time. Then in that case, you need to increase the number of the bombs. Let's say B is representing the bomb, and initially B will be 0. So you only require to update the number of the bombs if the start boundary of any kingdom is greater than the current boundary. In case that is equal, you don't require. Finally, you will print the number of bombs. Now to solve this problem, we will employ the C++ STLs. So to just solve this problem, we are taking a very simple approach of pairing these start time and the end time, and we will store the pair of these in the form of the vector. Now what we will be given? We will be given the number of the test cases, and if we take the current test case, then we have 1, 3, 2, 5, and 6, 9. Earlier to this, the number of boundaries will also be given, or the number of kingdoms will also be given. So we have this start boundary and the end boundary. If I say that the start boundary is A and the end boundary is B, so for each of the kingdom, we will be given this A and B. So if I take this A and B as the input from the user, and we have to sort this according to the end boundary. Let's make a pair, a vector of pairs. So we are making a vector of pair, and the pair we have integer and integer. Let's say the name of this vector is V. We will push this A and B in the order of B and A. What advantage we will get by storing this in the B and A is that we will have the finish time first, followed by the start time. If I sort this vector, finally we will sort this vector. So if I sort this vector according to the start, according to the first parameter, which is the B, so we will have the activities, or we will have the boundaries of the kingdoms sorted in the end boundary, or sorted according to the end boundary. And so this advantage we'll get by storing this pairs, or storing this A and B in the form of B and A. It means end boundary followed by the start boundary. Rest of the things will remain same. Let's move to the Codechef platform and solve this problem. So here I have already written the code. What we are going to take, we are going to take the number of the test cases from the user. And in the main, the number of test cases have been taken. And according to each of the test case, we are calling the fun function, which will be solving this problem. So very first, we have taken the vector of pairs of type integer integer, that is named as P. We have taken the number of the bombs initially as 0. And then the initial time has been initialized to a very large value. And we are setting the initial time to the very large value just because this initial time can be anything in between 0 to the limit of the long long. And if we find that the initial time of or initial boundary of any kingdom is less than this, so we will update the initial time to that. So we are given the n different kingdoms. For each of the kingdom, we are putting the start and the end boundaries. And for start and the end boundaries, we are pushing them in the order of b comma a. So initial time is actually initial boundary. So just to correlate that with this. So if the initial time or if the start time of any boundary or start boundary of any kingdom is less than the initial boundary, so we will update this to a. So instead of taking this time, we can take that initial boundary. Okay, so we have changed all the initial time to initial boundary. Now, having taken all the inputs from the user and setting up the initial boundary, we will have the first start boundary of the kingdom in initial boundary, and then we will initialize this initial boundary to one less than the current boundary. For example, the initial boundary of the one of the kingdom is, let's say, 7. So we are going to initialize this to 6, or initial boundary to 6, such that whenever a new boundary is coming, we will update the number of the bounds. After this, we are going to sort this using the sort function in the C++ STL. And after sorting this, we will schedule this for the bombs with the solution that we have discussed on the whiteboard. So here it is said that if you are referring to any of the kingdom, then the second part is representing the start boundary, and first part will be representing the end boundary. So if the start boundary is greater than the initial boundary or the current boundary, then we will update the number of the bombs. And after updating the number of bombs, we will have to update the current boundary. So current boundary is set as the end of the boundary of the given kingdom. So initial bound is equals to vk.first. It means that we are setting up the current boundary as the end boundary of the kingdom that we have selected here. So ultimately, we will have the total number of the bombs that we are going to print as our output. So let's check it for the sample test case. So you can see that the sample test case runs fine. Successfully executed the sample test case. We're now going to submit this code. You can see that all the test cases have passed. So this has been successfully submitted. Thank you.